All right, so what do you know about slope? What do you know about slope? Okay, so it's how the line changes. What else do we know? Rise over run. What else? Awesome. All right, so we're going to start by looking at the different types of slope. So we have Hillary and Trump over there, and their faces are slope faces. If a line is going up like that, what kind of slope is this? It's a rise, but it's a positive slope. And then if a line's going down, it has a negative slope. Is that familiar from last year? And then draw a straight line for the nose, a vertical line like that is an undefined slope. And then a horizontal slope has a zero slope. So let's draw that in our notebook so that we don't forget. Alright, so now what we're going to do is we are going to fill in this note sheet with some facts about slope. So slope is going to go in the middle, and you can use colored pencils to fill it in so it's pretty. Alright, so hush. So what is slope? The definition of slope. Slope is the ratio of vertical change to horizontal change. And ratio is a key word here. Why do you think ratio is important?
Because it's the number that's involved. If you need to know numbers,
So it's a way of comparing numbers?
Yeah.
So ratio is comparing numbers, and we're comparing the vertical change to the horizontal change. Alright, questions on the definition box? Alright, now let's look at the characteristics box. So slope is, I think Dalton said, rise over run. And rise up is positive direction. And down is negative. And then looking at run, right is positive, and left is negative. So rise up, positive. When you rise down or fall, it's negative. You go to the right, it's positive. To the left is negative.
Kind of like drew pictures instead of real words. So I figured that was what you were doing. He's still got it down.
All right. Are you ready for the examples? So for examples, in the lower left-hand box, just one. We're going to do other ones in the notebook. All right, so I have a point here at 2, 2, and then a point at negative 3, negative 2. I have my line going through them. I can find the slope. Slope is rise over run. The rise between my points is going to be the vertical distance between them. So to get from here to here, how many blocks am I going? I'm going from negative 2, negative 1, 0, 1, 2. So how many is that? 1, 2, 3. It's a rise of 4. And what's my run? 1, 2, 3, 4, 5. So this one, I have a rise of 4 and a run of 5. So the slope is 4 over 5. Questions on how we did that from the graph? All right, so now non-examples. Okay, this only works for straight lines, so if I have a line that is not straight, could I find slope of either of these lines using rise over run? No. Yeah, so this would go on the non-example side. So when not to use it. All right, so the goal for our lesson today, we're going to use rate of change to solve problems, and we're going to find slope of a line. So rate of change is just another way of saying slope. It's your change in y values over your change in x values. So that, and rate of change is one of your vocabulary words. I gave you guys that vocab sheet. And so rate of change is ratio comparing your change in y over the change in x. Alright, so now let's look at an example. So we're going to look at using a table to find the rate of change and explain the meaning of rate of change. So rate of change is comparing your change in y to your change in x. So if we look here, how's our y changing? We're going from 76 to 152 to 228. So what's the change from here to here?
Well, if we don't know it off the top of our hand, we can subtract it.
Calculator.
Use a calculator.
It's funny.
Alright, so the change, so 152 minus 76 is 76. And then 228 minus 152 is 76. And this change from here to here is 2. And then from 4 to 6, we have a change of 2. So our change in y is 76. Between 76 and 152. And our change in x is 2. Can we reduce that fraction?
Yes.
Yes, because 76 is even and 2 is even. So divide, we get 38 over 1. And then is that the same between 4, 152 and 6, 228?
Yep.
Yep, because our change in y is still 76. And our change in x is 2. And that reduces to 38 over 1. So are we okay with that? Alright. So now looking at a graph. So it's asking us to find the rate of change from 2002 to 2004 and then from 2004 to 2006. So the first thing is we need points off of the line, right? So what was, how many passports were issued in 2002? Looking at the graph. 7 million, right? Alright, so we have a point at, and then in 2004, how many passports were issued?
8.9 billion.
Alright, so how do we find, so what's the rate of change in our y? To go from 7 to 8.9, how much are we changing?
1.9.
1.9. And then from 2002 to 2004, how much are we changing on our x-axis? To go from 2002 to 2004 is 2 years, right? So can we reduce this fraction at all? No, we're just going to leave it as it is. It's in the lowest form. So find the rate of change from 2002 to 2004. We're in 2 years. It increased because our line is going up. We added 1.9 million passports. Questions on that? Reading from a graph, are we okay with that?
Yeah.
So explain, what did that mean? I kind of just said it, but what did it mean, that 1.9 over 2?
Passports in 4 years.
Alright, so that means that there was an increase in 1.9 million passports in that 2-year period, right?
Well,
Alright, now if I go back and look at the graph, is the rate of change the same or different between 2004 and 2002 and then 2004 to 2006? Are they the same or different?
Slightly different.
Is this line, is it rising At the same